Hello, my name is Zicheng Wang, and this is my scene of post-apocalyptic visualization of Dublin City. In the scene, you can notice there are some dragons, monsters hanging around, and there are also some soldiers and heroes trying to defend their home. The first part of this video is three-dimensional objects and views. One 3D model consists of meshes, nodes, materials, and animations. In my opinion, rendering the 3D model means you need to use all vertices in every mesh, and after rendering all these meshes, you can get the 3D model you imported. Moreover, it is also noticeable that the vertices in every mesh will be connected through triangles. When you want to see something in the OpenGL program, you need a view matrix and perspective matrix to make the model show into the camera. Vertex position will be come to the camera space through view matrix, and it will be clipped by the perspective matrix. Now is the second part, user interaction and camera control. I can use WASD to control the position of the camera. Moreover, if I drag the mouse, it will change the direction of the view. Using the pitch and yaw, Euler angles can make that. First, these are the two images how the pitch and yaw move. The camera will look up and down by changing the pitch, and the camera can rotate through y-axis by changing the yaw. And if we are going to calculate the from direction, and actually y part is perpendicular to the x and z panel, so the y direction is sine pitch, and the cosine pitch is the part of the xz panel to do the calculation. Then process with the xz panel. According to the image, we can easily get the related parameters. This is my hierarchical animated model. Due to the time constraints, I will only illustrate the bone transformation part in this model. The image above shows the people with blue nose. In the animation, each nose has its own transformation, which is calculation result of the position, rotation, and scale. After having the transformation of the node, we need to consider the effect from the parent's node, because the animation involving hierarchy movement, so each node will need to consider the effect from its parent's node. It is like the effect on the root node will eventually be reflected on the child node. Then we get the actual node movement in the world space, and using the bone offset, we can get the actual bone movement. The fourth part is required of a crowd of moving characters. In my scene, there are some soldiers and aliens walking back and forward. And I basically have two methods to realize that. The first method is using the technique of ping-pong animation. The ping-pong animation means I cut the duration into half. In the first part, the system play the keyframes in normal phase, and the 3D model will play walking backward animation. And when the system detects the half of the duration pass by, then it will play the animation in the opposite phase. It will realize the function of walking forward and backward in place. Now we need to calculate the timing of the when the model will walking forward and backward, using offset to accumulate the sum of the translate, then using GL and translate to applicate the movement. And the second method is using the pure animation. The fifth part is texture mapping the scene with using the image file. In this case, I need to use two parts of the model, meshes and materials respectively, to make the texture mapping on it. First, after we importing the model will give us the directory of the texture. We need to use this file to load the image. Then, using OpenGL function, to transport it into the GPU, and GPU will return us the ID for us to use. After processing all the materials, including the texture, the next step will be drawing the model. Each mesh has its own material ID. Based on this rule, we can get the material and the texture we already processed in model. Then using GL bind texture can specify the corresponding texture and transmit the texture into the shader. Finally, using the GL draw arrays will let the OpenGL draw the corresponding texture on the corresponding meshes. The sixth part is foam illumination. This illumination consists of three main parts: ambient, diffuse, specular. First of all, in the fifth part, we already processed the material, and in these materials, I have Ka, Ks, Kd, which means the material properties, and it is actually the RGBA data. When processing with ambient, we only need to use the ambient color to multiply the value of the ambient parameters. For the diffuse, it is based on the light position. We can use the picture above to calculate the cosine value between light direction and the normal. And getting the angle, I can use the angle, diffuse color, diffuse properties, which is material properties, and the texture coordinates to get the diffuse I want. Finally, the specular. We first need the direction from the light to the object. Secondly is the normal of the object. To calculate the reflected light, after getting the reflected light, I can use the camera position to calculate the angle between these two lines. And using the corresponding materials, the related data can be calculated. And the sum of these three parameters will be for illumination from the first light source. Since my scene there are two light sources, so system will repeat the same process but using a different light source. The seventh part is the skybox, which is also known as a cube map. I need to import the sixth image into the GPU in the same manner, but with different parameters. In this case, I have to specify the vertex position. Each image is composed of two triangles, meaning each plane needs 6 vertices. Based on this, we can use the vertex position and the textures to complete the cube map. We need to set GL dipsmax to false to ensure the skybox is rendered behind all other objects. Additionally, we must remove any translation components from the view matrix to prevent the skybox from moving. That's all for my video presentation. Thank you for listening.